You ever wonder how your streaming service just knows the exact movie you're in the mood for? Or how your phone's assistant actually gets what you're saying? Well, that magic has a name: deep learning. And in the next few minutes, we're going to pull back that curtain and really see how it all works. So let's kick things off with a pretty serious warning from Mark Cuban. And you know what? He's not exaggerating. This stuff is moving so incredibly fast that understanding it isn't just a cool hobby anymore. It's becoming absolutely essential. All right, here's the game plan for this explainer. We're going to start with the basics, what deep learning even is. Then we'll dive into its incredible superpowers. After that, we'll look at the hidden costs, navigate the tricky ethical questions, and finally, figure out when it's the right tool for the job. Okay, first things first, what is deep learning? To really wrap our heads around it, we need to zoom out a little and see where it fits into the whole AI universe. It all begins with artificial intelligence, or AI. The best way to picture it is as a giant tree. AI is the entire tree, the whole big idea of trying to make machines smart. Now imagine a massive branch growing off that tree. That's machine learning. This is where instead of writing out tons of rules, we just feed a computer a whole bunch of data and let it figure out the patterns for itself. And then, growing off that big branch, we get to deep learning. And this is where things get really fascinating. The deep part comes from using tons and tons of layers of something called artificial neural networks, which are basically complex systems designed to work a bit like our own brains. So, how does one of these networks actually think? It's surprisingly logical. First, the input layer just takes in the data, let's say all the pixels in a photo. Then the hidden layers, and in deep learning, there are a lot of them, get to work processing that data, finding patterns inside of patterns. And finally, the output layer gives you the answer, like, yep, that's a cat. So how do they actually learn to do that? Well, it's actually a lot like how a toddler learns. You don't give a toddler a dictionary definition of a dog. You just point to different dogs and say, dog, over and over. They see thousands of examples and their brain just gets the pattern. Deep learning is the same idea, just with millions or even billions of data points. Okay, now that we've got the basics down, let's get to the fun part. Let's talk about deep learning's superpowers. What makes this stuff such a revolutionary game changer? The first superpower is what's called automatic feature learning. So instead of a human programmer having to tell the computer, hey, look for whiskers and pointy ears, the network figures out the important patterns all on its own. This leads to just mind-blowing accuracy. And the more data you feed it, the smarter it gets. Plus, it's super versatile. It can handle images, text, sound, you name it. And you can see these superpowers changing the world all around us, right now. In hospitals, these systems are spotting diseases in medical scans, sometimes even better than a human doctor. On the road, deep learning is the brain that powers self-driving cars. It's the reason your streaming service is so good at recommending shows, and it's how your bank can spot a sketchy transaction almost instantly. Let's look at some actual numbers here. This chart shows how well different kinds of deep learning models do on a classic test, just recognizing handwritten numbers. I mean, look at these scores. We're talking over 98% accuracy. That's practically perfect. It shows you just how powerful these things really are. But, and you probably knew a but was coming, all of this amazing power comes at a really steep price. And I'm not just talking about money here. This number is just staggering. Training one single large deep learning model can produce 284 tons of CO2. To put that into perspective, that's the same carbon footprint as about 60 cars on the road for an entire year. It's a huge reminder that this digital tech has a very real, very physical impact on our planet. And that huge environmental cost is directly linked to these other big drawbacks. Deep learning needs incredibly powerful, super expensive computers that just guzzle energy. It's totally dependent on having absolutely massive amounts of data, and you need some seriously specialized experts to build and manage these things. But the costs aren't just about computers and energy bills. Once you get past the technical hurdles, you step right into a complete ethical minefield. This leads us to one of the biggest challenges in AI today, what everyone calls the black box problem. So what exactly is it, and why is it so concerning? Well, here's the core issue. With the most advanced deep learning models, we often can't actually see why they made a certain decision. The internal logic is totally hidden from us inside a black box. Now, you can imagine why this is a massive problem in fields like medicine or finance, where you might be legally required to explain your decisions. And hey, if it makes a mistake, how can you possibly fix it if you don't even know how it was thinking? And that black box can hide an even more dangerous problem: algorithmic bias. This is what happens when a model learns the biases that are already present in the data we feed it. For instance, there was this shocking, real-world case where an algorithm trained mostly on pictures of white people was given a blurry photo of Barack Obama and asked to enhance it. The result? It produced a picture of a white man. It's a stark example of how these systems can amplify our society's worst biases. So, with these unbelievable powers on one side and these really serious dangers on the other, how do we decide when, or even if, we should be using deep learning? It really comes down to a few key things. Deep learning is an absolute superstar when you have enormous, complex sets of data and when the old-school models just aren't cutting it. But, and this is a big but, if you don't have much data, or if you absolutely positively must be able to explain how the model reached its conclusion, you should probably look for another way. It's all about picking the right tool for the right job. And that brings us to our last question, and maybe it's the most important one. As we build these incredibly powerful systems, we are literally encoding our values and our biases into them. This isn't just a technical challenge anymore, it's a social one. So the question we all need to start asking ourselves is this: who gets to decide what those values are?